today's lecture, we're going to look at Venn diagram and set operations. The first example here, we have Venn diagram given with only one set, right? Set A. And we call this as union set with U. We're going to see if we can list the given set. So for unions of the set from given Venn diagrams, this is going to be, you have inside union, you have set A, which include element 1, 5, 6, but outside of that set A, you also have 7 and 9. So that's going to be your unions. So all the element inside of that Venn diagram is going to be unions. And set A, you only have 1, 5, and 6. And the third one, it's the set of element in union set that are not in A. So element that's in the union but not in A is going to be 7 and 9. What about example 2? If you have 2 set is given, right? So let's look at the union first. Unions, I have A, B, C, D, E belong to set A and B, but also outside I have F and G. So that's going to be union set. Your B is going to be inside of your B circle. So it will be D and E. And then the set of element in A but not B. So it's in A but not B is going to be A, B, C. You don't include D because D is in B, right? The next one is asking the set of element in unions that are not B. So it's inside union but exclude set B, right? That's going to be A, B, C, and F, G. So just exclude D, E from unions. The last one on that problem is set of element in both A and B. When it's a N, we need to make sure we're looking for intersection of those two sets. So the element have to be in A at the same time, and B is going to be intersections, which is going to be D. This area, right? That's intersection of those two. And you can use A intersect B. Example 3, given union being 1 through 10. So all the natural number 1 through 10. And A is going to be 1, 3, 7, 9. It looked like an odd number without 5, right? And then B is going to be 3, 7, 8, 10. And see if we can find each of the following set. The first one is easy. So set A is 1, 3, 7, 9. And so if we wanted to find A naught, which means that's outside of A, we will say everything from 1 through 10 excluding A. So it'll be 1 exclude, 2, 3 should be exclude, 4, 6, 7 should be excluded, 8, 9 should be excluded, and 10 will be A naught. And if we wanted to find A intersect B, we call this is intersection, which means overlapping area of A and B. So overlapping elements between A and B, I see 3 and 3, 7 and 7, right? So it's going to be 3 and 7. And what about A union B? The union means everything A and everything B. Just make sure if you have the same element, you just need to write one time. So this, everything A, start with 1 and 3, and then you have 7, and B you have 8, A you have 9, B you have 10. Right. So everything from A plus B is going to be A union B. What about D? A intersection of empty set. Well, empty set intersection with any set is going to be empty, right? Intersection, so overlapping, the same element will be empty, nothing, right? What about union of B and empty set? So then it should be just the set B. 3, 7, 8, 10. So everything in set B is here, and everything in set empty set is empty set, so nothing is added in. What about if we're looking at F? You have A union B not. So we need to find A union B first. And we had that from here, right? So this is A union B. Not means from the union set, exclude that A union B. So let's see. Exclude 1, but 2 should be there. 3 exclude, 4, 5, and 6, and 7, 8, 9, 10 will be excluded. So that's going to be A union B not. What about the next one? In order to find A naught intersection of B naught, we need to find A naught and B naught first. And look like I have A naught here. So let me write the B naught. Let's do that with black, since that's not a solution. So B naught is going to be 1, 2, 4, 5, 6, and 9, right? So if we wanted to find intersection of these two, intersection, I have 2, and looks like I have 4, 5, and 6. That's it, right? Okay. And if we're looking at H, we wanted to do A union B naught. We have A here, B naught here. If we wanted to find unions, just include everything from A and everything from B naught. So if I write that, it will be 1, 2, 3, 4, 5, 6, 7, and 9. The last one, we wanted to do A intersection of B naught. Do we find A intersection B before? Yep, right here. So A intersection B. That means from the unions, everything but 3, 7. So everything but 3, 7 will be 1, 2, 4, 5,